Hi everyone, in today's chemistry video, we are going to talk about how boiling and melting points are affected by geometric isomers, or also known as cis and trans isomers. So, under isomerism in organic chemistry, there are two things, structural isomers and stereoisomers. Structural isomers are isomers that have the same molecular formula but different structural formula. Meanwhile, stereoisomers are isomers that have the same molecular and structural formula but different 3D arrangement in space. Under stereoisomerism, there are optical isomers and geometrical isomers. However, today we are only going to focus on geometrical isomers. Geometrical or cis and trans isomers are isomers that exist only if there is a double bond, so they can only be alkenes. Each of the carbon in the carbon-carbon double bond must also be connected to two different groups of atoms. So, cis isomerism would have the same group of atoms side by side, while trans isomerism would have the same group of atoms diagonally. The similarity between these two examples is that they both have the same molecular mass, since any alkene that possesses cis isomerism would also possess trans isomerism. However, there is a difference between the two in terms of polarity. In cis isomerism, the electrons are pushed towards the top in this case, causing an imbalance of charges. In other words, the dipoles are not cancelled. This causes the cis isomer to be slightly more polar. Meanwhile, for trans isomerism, the electrons are pushed towards opposite sides, so the charges as well as the dipoles are cancelled, so the trans isomer is less polar. This difference in polarity helps to determine the difference in boiling points between cis and trans isomers. For more polar molecules, such as molecules that possess permanent dipoles, they would have more or stronger intermolecular forces, which causes more energy to be required to break these bonds, and so the boiling point increases. And vice versa, less polar molecules would have less intermolecular forces, so less energy required to break the bonds, and so boiling point would decrease for trans isomers. Many would suggest that the melting points of the isomers would behave in a similar way to the boiling point. However, the melting points actually depend on the packing or arrangement of cis and trans isomers. So when we represent the cis isomer in this way and arrange it together, there would be many gaps that could be found in between, meaning that it is less compact, so less energy is required to break them apart, lowering the melting point. However, when we represent the trans isomer this way and arrange it together, less gaps can be found in between, meaning that it is more compact and more energy would require to break them apart, causing an increase in melting points. And that's it today. Thank you for listening.